Welcome to the AI in Manufacturing podcast here on Industry 4.0 TV. I'm your host, Kudzai Manditereza, and joining me on this episode is Renan Devillieres, who is the founder and CEO of OSS Ventures. In this episode, we're going to discuss quite a wide range of topics, including why factories need to operate like tech companies, why most manufacturing AI initiatives start wrong, what the factory floor actually needs as AI solutions, and what it actually takes to scale AI in manufacturing. And Renan is going to also give us a very unique perspective that he has as a venture builder, understanding both sides of the coins, the end users, and also the builders of these solutions. So before we get into all of that, Renan, I'd like to welcome you to the show here. Thank you so much for joining us. So could you
Thank
please
you for
start off
having me.
by really giving us an introduction about yourself, tell us a bit about your background and about OSS Ventures.
Sure, and thank you for the invitation. It's a blast being there. So I was a kid that was good at math. So I went to a French school and high school, and then like university teaching math, and I loved it. And then I joined a consultancy company called McKinsey and Company by pure luck. I was just wanting to go into business, and nobody in my family knew anything about business. So I literally Googled what is the company that creates the most CEO, and on Google it was saying McKinsey and Company. So I joined, and I think they saw a young guy good at math with zero business knowledge, and they said, "Hey, let's get the guy to do supply chain." So my first mission was supply chain. This was my first time in a factory. I just loved it, and so for the next 15 years, basically, I've been working in factories all of my life. So I was a consultant, then I became a factory director, quality director, supply chain director. At some point, I was in the COO office of Richmond, the luxury group. You may not know Richmond, but you for sure you know Cartier, like the jewelry maker and everything. So loved it. Did that for like 10 years. And then I always loved coding and tech. So I created a tech startup in San Francisco with co-founders. Did like the most stupid things for like 1 year because I didn't know what I was doing. But after 1 year, we found product market fit, and we went from 0 to 140 employees in like 1 year, raised a bunch of money, ended up selling my shares. So I made some money. And after making some money, I was like, what can I do with my life? I was too young to retire, and my wife told me like just go outside and take a job because I can't stand you having you like in the morning in the house. So figured out I had to do something, and I launched OSS Ventures. And so OSS Ventures is a venture builder. So what we do is we go to factories, we look for pain points that can be solved with technology and AI. When we find a good pain point, we build the solution. So I have 20 coders, designers, and everything. We build the solution, we solve the pain point, and when it works, we literally call founders and we say, hey, you're a tech founder, you sold your company. Do you want to take the helm of that thing that we created? And they become the founders of the company, and the company becomes a separate entity. So we are 5 years old, based in Paris and Boston. We started 30 projects. We have 22 companies that were spun out of the studio. We're live in 3,800 factories all over the world, 200,000 monthly users, and all of our companies are doing 41 million euro revenue. So that's what we do.
Fascinating. So I'm really looking forward to unpacking all of that with you. You've quite a really interesting background, so I'm really excited to dive in here. So I mean, just to kick things off here, I mean, something that I agree with, that you mentioned in one of your I think it's blog post or website, where you talk about this idea that a very small percentage of factories today actually operate like tech companies,
Oh yeah.
right? And I think you had said 5% of was that.
Yeah.
And so I just kind of like want you to paint a picture for us on what does a tech enabled factory actually look like compared
Yeah.
to the other 95% that is not tech enabled.
Well, the first, it's about the business model and the margin. So a Tesla car made in Austin, Texas, costs about the same to produce as the Tesla that gets out of the Shanghai Gigafactory. And why? Because humans have a lot of leverage. And so you don't really care about how much you pay the humans, because like 5 humans can create a lot of cars. And so a truly tech-enabled operational company looks like a tech company because people are well paid and there are less people to do the same number of jobs. That's the bulk of the thing. And then that has a lot of consequences: how you handle code, how you handle operations, how you think about recruitment. But let me just take a very concrete example. I'm a very concrete, pragmatic guy. Um, you know what industrialization is? Like coding the machines. Okay. Um,
Yeah.
in your typical Stellantis BMW factory, there will be like 15 guys coding 30 machines. Those people are not paid that well. I don't know if they are good or not, and they do the programming over and over and over again for each new model and whatever and whatever. Okay. At Xiaomi, there are 5 guys paid 500,000, and when they code, it is sent to like 20 factories, and the
Yeah.
code is duplicated amongst all machines. And so those people are well paid, but when you divide the salary of those 5 guys by the number of cars, it's cheaper than the guys at BMW. And so that's the difference. And that's
Yeah.
happening all across the board.
Yeah. And I think it's a mindset shift. And I think I remember reading, a, a quote from some respectable analyst in the field was talking about this idea that you have to start thinking like a software company, obviously, if you're going to be competing with Tesla, right? And I think that's such a huge shift, because in manufacturing, we're used to dealing with electrical engineers, mechanical engineers, right? And even the tools themselves are built for electrical engineers, mechanical engineers, and software engineer, but not software engineering. So I think that's also, a huge shift that is still required there for manufacturers to adopt. So maybe I just kind of want to get your sense on what have you seen. Like, you have visited a lot of factories, I think about 1,700 manufacturing sites, and you mentioned 3,800 that you are, servicing. What have you seen as the pattern that, shows up repeatedly for this other 95%?
Yeah.
What are those things that they're doing wrong?
So first, like that's the mindset, but there are the skills. So if you go to Tesla, if you go to Xiaomi, if you go to Michelin, the tire maker, if you go to those tech-enabled factory companies, there's at least 2 or 3 guys in the executive committee who understand code. If you go to Tesla, you have ex-Apple engineers all around and everything, everything. And so you need the skills. Like I'm always saying the same thing to my manufacturing clients. They don't like it, but it's true. I said to them, okay, would you give a factory director position to someone who never read a plan in his life? And they all say no. And I say, so why the heck is your digitization guy someone who never wrote a line of code? And so it's about skills. The thing is, a lot of tech people, they think they are too good to work in factories, but they are not. They should go. And so the main thing is skills. Then you have organization. So, for example, like the thing that Tesla basically invented is to say, okay, the car is an object. Every object that is connected needs to have an operating system. And so we need to have an operating system of the car. And so they basically rethought every single function of the car to be piloted by a central operating system. Another way of thinking about tech is to say, if there's an operating system, then you can update the operating system via Wi-Fi. And so you can literally update your car via Wi-Fi.
Yes.
Except for Xiaomi and BYD, no other car company has a car that can be updated by Wi-Fi. And so that is a way of thinking the physical product as the basis for a software platform. And that is a way of thinking that has been like for decades in the tech industry. But those people in the automotive industry, they have like 50 different suppliers providing 50 pieces of software and local things that are not interoperated and everything, because they don't think like that. They think in parts, they don't think in systems. And by the way, it is true for aeronautics, it is true for kitchen appliance, it is true for a lot of things. But I see the companies outperforming and being tech companies thinking their product at platform with a unified software layer. And that is very easy to spot.
Yeah. I mean, someone would argue that, I mean, you spoke about the issue of, skills and well-paid jobs in manufacturing. Someone would argue that it's easy for, for Meta or, or Google to attract top talent because traditionally this is where they've always gone. This is where the cool kids hang out. But manufacturing has got an image problem, I would say. No one is really excited about, going to work for a manufacturing company. Do you have any thoughts on,
Yeah.
on that?
So my daughter is 4 years old. I want that by the time she's 15, I can tell her you need to go work in manufacturing because it's the coolest place to be and you'll be well paid. Today, I cannot say that.
Yes.
But in 11 years, I will be able to say it because that's what I'm working on every day. And so what you say was true 5 years ago, but now, like being an engineer at Tesla or SpaceX is really cool. Being an engineer at Android is really cool. And I
Yes.
think the next generation of manufacturing companies that will be dominant are also the ones that solve that issue. But in my mind, it is kind of the other way around, which means it will be never cool to do software engineering where you program machines, but you only program 3 machines and it's a low paid job. Like there's no way in hell that this is cool. If you have a job where you program 400 machines and you have like AI doing part of the coding and you're in charge of the system and you are well paid because you create a lot of value, that will be cool. And so a lot of manufacturers, a lot of people from the factories, they meet me and they say, I have a talent attraction problem. And I tell them, I don't think you have a talent attraction problem. I think you have a system problem that makes it so that people are not that well paid and everything. And so you cannot attract talent. But let me say, if you have a $500,000 position open to be able to program 400 machines and print tens of millions of money because you implement AI and everything, people will line up out the door.
Oh yeah, absolutely. Yeah, I mean, talking about, like a vision, like you spoke about this idea that you want to be able to, in 5, 10 years, you want to be able to, to sort of like talk to your daughter and tell her how, she needs to go into manufacturing because it's such a cool place to work at. And I'd like to talk about also some of the numbers. And the reason why I like to talking to you here is because you've got all these concrete, numbers and figures that you put out there. You mentioned that like within uh, 5 to 50%, you want to be able to move that number from 5%, where only 5% are tech enabled,
Hmm.
to about 50% within a
Yep.
decade,
Yep.
right? So I want to get a sense of, what makes you believe that it's achievable now when it
Yeah.
wasn't before.
So I'm an economic history geek. And so here is what I think is happening right now. I think what is happening right now is exactly the same thing that happened in the beginning of the 20th century when we first put the machines in the factories. So there was no machine. So there was like 300 people working and doing physical things. In 10 years, there was like 2 to 3 times less factories, but the one factories that were operating with 10 times less people, and those people were programming the machines. And so you could pay more people because they had leverage in the form of machine. I think what is happening with AI is that the physical leverage that happened in the beginning of the 20th century is becoming intellectual leverage. And that is very concrete. Like I'm out from a factory in Istanbul, Turkey. We are replacing 55 people who are doing research and development activities for subs. And we're replacing them with 5 people and an AI that does the work that was previously done by people project by project. And so if you look at history, it happened. And so I think it will happen again. So not every factory will make it. It is hard. And like there is the social component, which is hardcore, but it will happen. and it should be done with like ethics. But this, like the tech is too powerful, and also it's already happening. Like there is that Chinese company called Shein. Their supply chain department is like 100 people for a $30 billion company because it's AI doing everything in the job. So it's already live in some very forward-looking companies, like that is live in SpaceX, that is live in TSMC, that is live in Xiaomi. So those things are live, the tech exists. So now it will spread to factories, but some factories are not going to make it, and that's okay. It's called capitalism. I mean,
Oh, yeah, absolutely. I mean, talking about, AI, it's obviously, as you know, it's really, taking over, in many different industries, manufacturing included. Uh, you know, but somewhat, I believe in manufacturing, we've got this paralysis, I would say, where because it's not something that we've traditionally known how to apply in manufacturing, things like AI. So a lot of companies are still going through that phase where they don't really know how to find problems to solve with AI, or and or how to really operationalize it, right? So, and I think at OSS Ventures you've got this concept of industrializing discovery,
yeah.
right? So for our listeners who are leading AI initiatives inside manufacturing companies, can you explain what that means and why you believe like this is the most under leveraged phase?
Yes, so 100%. I'm so happy to get into the weeds with you. So, some basic stats: 85% of AI projects fail,
Yep.
and we have failed about 30% of our AI projects in the last 2 years. But now we are on track to, like, and we deployed over 100 factories in the last 2 years on specifically AI native projects. So here are our main learnings. The first is AI projects in production are expensive. What is not expensive is just if you ask ChatGPT to do a quote, it will do it.
Mm-hmm.
It will just be false, but it will do it. And so it is expensive, it is hard. So you should choose big problems and not small problems, a limited number of big problems. That's insight number one. It's costly, so you should choose big problem. Insight number one. Insight number two, in the 8 last projects that we did with Gen AI does the code, but then the code does the output. Like we have an AI project in aeronautics company. You're not vibe coding your way to create an airplane, let me tell you. So Gen AI can and should be leveraged to create the code, but then the code is deterministic, it is auditable, and so you can put the code in production. So that's the second insight. Every single one of the 8 projects that we did, Gen AI is actually used to create the code. That's second. Third insight is it's not because you have data in your ERP and systems and MES that you have an AI ready system. About 30 to 40% of the data points are in the heads of the people in the know. So, for example, for my socks factory, we are automating research and development. There are 850 rules that lived in the head of the research and development people. And that was the algorithm that they had in their heads to be able to do the research and development on the socks. And so you have to go on the shop floor, you have to work with those people, and you have to get that out of their heads because it's not in any system. So that's insight. And the last insight is you don't go from 55 people to 0 people. You go from 55 people to 5 people. And those 5 people, what are their job? Their job is managing the system. So the system needs to be managed. So someone needs to be able to understand the system, to understand the rule, to understand the code, to do quality, to have some quality gates and saying, okay, I'm okay with that output. I let the output to the system. They need also to be able to nurture the thing and to say, oh, I discovered that new thing in the factory, so I'm adding that new rule, or maybe that rule was true 1 year ago because there was a certain type of machine, but now it's a new rule and everything. And so humans need to be in charge of the system. And once again, to me, it's very funny because we discovered that through working with factories,
Mhm.
but it's very alike when we put machines in factories. Like when we put machines in factory, there are people who code the machine, they understand the machine, they do quality work, they need to understand what the machine is doing. And so there are people managing the machines. It's just a small number of people and a lot of machines. And so the new machine is AI, but you need to design the experience of the people managing the system. And that should be the factory people. It cannot be you as a software provider. It needs to be the software people. And so, if I dare to say so, I think we're becoming quite good at designing the systems and implementing them, mostly because we are on the shop floor all day and we failed a lot and understood a lot by doing that.
Yeah.
But those are our main learnings.
Absolutely. And I mean, I 100% agree, especially with, your third point on this idea of, tribal knowledge, like having all of this knowledge existing in people's heads. I mean, I speak to a lot of AI in manufacturing startups on this podcast. I would say overwhelmingly about 80% of them are solving that exact problem, where it's really about capturing that tribal knowledge. That's, in my view, is the is the lowest hanging fruit as far as AI manufacturing concerned. Yeah. So I mean, I would like to go a little bit deeper, especially on the building aspect of it, how you
Yeah.
approach building this. I think you mentioned that you validate sort of like 6 fundamentals before you build anything, which
Yeah.
is the problem, user dynamics, causal mechanism, solution hypothesis, economic logic, and go-to-market mechanism.
Yeah.
Can you sort of like walk us through how this works
Yeah.
in practice, and maybe if you've got a real example from one of
Sure.
your startups?
I can also give you examples of failures because we learn a lot from failures.
Yeah.
So I'm a former factory director. So in my head, things are processes. And so we have a process of discovery. And so the process of discovery is I have someone in my team who calls factory directors and say, hey, if you want, you get a bunch of tech people, ex Google, ex Meta, and everything. And we go to your factory. We look at everything in your factory, all the pain points, all the economics. You give us your P&L and everything. And we give you a report with AI and tech opportunities with a number and a benchmark. And everything that I just said is free for you. And so my team has done 900 of those factory visits. And so we have a gigantic database, and every single user research is filmed. So we have the video, transcripts, and everything. So we have a constant stream of information. So now that we have that constant stream of information, we are very rich in knowing what happens. Now that we are very rich in knowing what happens, we choose what to work on. This is very important. We don't work on what people tell us to work on. We work on what we choose to work on. And so what we consider a good problem is something that can be built without, like, there is no fundamental research and development risk. Like, we don't need to publish a paper in Nature solving some fundamental physics or math problem to create a company. So we only do things where there is no fundamental research risk. We take operational risk, but no research risk. That's one.
Mm-hmm.
Second is we have that concept called the 10x. And so the 10x is when we succeed at creating that piece of tech, it needs to be 10 times better than the alternative. So for example, the SOX R&D is, it used to take you about 4 to 6 months, 8 iteration, $35K in human time to create a new SOC. With our AI, it's going to be 1 week, 80% of SOCs. New designs are not going to be touched by any human, and it's going to cost you 2K. So it needs to be 10 times better. And with numbers, it's not feelings, it's numbers. When we have that concept of the 10x, we go to factory directors and we say to them, hey, you remember us? We came like 4 months ago in your factory. We found that. Here is our proposition with the numbers. Do you agree to work with us? You pay nothing until it works, only our Like I pay for the devs, I pay for I pay for everyone basically, and we work until it works. And when it works, you pay this amount. If we contact 10 factory directors and at least 3 say yes, then we launch. If less than 3 say yes, we don't launch. Because sometimes we think something is cool,
Yeah.
but factory directors don't think. So it's very important for us to have that reality check, and in the form of money, because people are nice. So they will say, "Ah, that's amazing. Your idea is amazing. Do it."
Yeah.
Yeah, but what about the money? No money. But amazing. Keep up what you're doing, and so don't do that.
A
So when
hundred.
we have that,
Mhm.
then we launch,
A
and
100%.
that's our process.
Super interesting, and I think it kind of like it's a good segue into also what I wanted to discuss with you, as far as for a lot of builders, like you mentioned, a lot of the stuff that I maybe I see a lot of people have got something that looks good on a pitch deck, but really no one is prepared to pay for it, right? So maybe to kind of like give a sense to our listeners who may be builders on a what are the top AI use cases that come up as sort of like genuine pain points, as you sort of like go through into factories and survey both management and frontline operators. What are those top use cases that come up time and time again?
I would say a very simple heuristic is just open your eyes and like be lean, do a Gemba walk, look at pockets of people with 35 megabytes Excel files being bottleneck to everyone.
Yeah.
Each time there is that situation, it's a potential for launching something, basically. So I won't answer with like specifics, but let me give you an example. Like 3 days ago, I was speaking with an aeronautics CEO, tier one, good company, 10 factories. And I told him, okay, what's on your mind? And he said, well, great news. I got 2 new clients. I said, great news. And he said to me, bad news. It means that I have 13,000 hours per month of industrialization, doing only like new programmation, but also like standard operating procedure and things like that. And I I can tire 2 guys, much less 30 new guys. And I was like, AI agents, let's go. What about those 13,000 hours getting down to like 200 hours? And that was it. That was how to spot the opportunity. So just open your eyes, look at the pockets of things that are not going right, with a lot of people being bottlenecked with like very manual things, and like be open. Like, let me give you a very specific example. So we have that process of discovery and everything. My team pings me and say, "Hey, we had the weirdest call. Like some guy on an oil rig in the middle of the ocean
Yeah.
called us and said, "Hey, we are working in one of the most dangerous environments because it's literally the middle of the ocean and we are doing very dangerous activities. So we have 3 doctors on board and they are using Excel files to manage the health and safety of everyone." So we went there and we created their software, and turns out that our rigs, mines, like literally mining operations, cargo ships, all those places, they are doctors and they had no software. So we created their software. I mean, in a million years, I would not have thought of that. So,
Yeah.
yeah, it's just about the humility of going to the shop floor and just listening and looking at what's possible.
Yeah, 100%. Yeah, I mean, I think there's just so many challenges to getting AI working in manufacturing. So on one hand, I mean, we spoke about this idea that if you speak to, say, a few leaders and they're willing to pay for it, then you launch, right?
Yeah.
But then on the other hand, you find this friction sometimes where the IT director thinks it's a good solution, right? And yet the frontline operator is not exactly how they interact with software. So maybe they send a chatbot. So maybe sometimes the frontline operator doesn't really naturally interact with the chat surface, right? Or sometimes you send an AI solution that has got a long list of fields that someone has to fill. Meanwhile, they just want to concentrate on doing their job. They don't really want to. So usability, I find, is also a big usability. Sustained use of AI is a big issue. So I wanted to get your thoughts on what to you, is usable AI, or what should builders pay attention to more to sort of like make AI adoption and sustenance eh,
Yeah.
possible.
So several things to unpack here. One, I don't think AI is an horizontal play. I think it's vertical per vertical. So you get the AI for R&D, you get the AI for quality, you get the AI for industrialization, because different job, different context, different data, different tools, like everything is different and it's hard.
Mhm.
So I don't buy the horizontal. So I don't think everyone will have like a magical thing that solves everything. Maybe I'm wrong, but I don't buy that.
Yeah.
Second is, if if you think that it's the same job, then you're wrong. It is a different job. You are now the manager of AI agents. It's a different job. But it means that designers should be really, really good at designing the products that make someone feel in control of that system, understand how it goes and everything. Each time we have been successful at creating the right environment for someone to feel in control of what's happening, adoption was instant. People like it, people understand. And at some point, I was like, maybe with AI, I don't need designers anymore. I need more designers, because designing for that new experience of being the manager of agents is actually very hard. And you cannot take a software engineer and put him or her in charge of being the manager of agents. You need someone who knows the work. So for the manager of the AI agents doing quality, you need someone who's really good at quality. And it's your job as a software maker to be good enough at design to provide an experience where you, the best guy at quality, you can code, you feel in control of the agents working, and you see your system and you leverage it. And that's really hard.
Yeah.
So I think most products are very badly designed. And also, there is not the proper amount of care in the experience of those people who should be manager of agents. And we tech people are guilty of imposing all complexity on the users. And that is one big reason was why a lot of AI implementations fail. Then, of course, there's change management and everything, but it's a bit like the talent problem from the factory directors. I tell them, hey, if you have a system where you pay people well and the job is interesting, you won't have a talent attraction problem. I don't think that people are against AI. I think people are against bad products. And it's our responsibility to create good products. And most products that we tech people do are very bad. And so it's our job to do good products.
Yeah. 100%. And I think one of the other patterns that I've seen also, in my experience in how companies approach building AI for manufacturing is this. On the one hand, it's companies who are embedding AI into products, and then there are companies who are reimagining that and saying, okay, actually this needs to be a new layer, right? It needs to be a different interface altogether. What are your thoughts in this idea that, okay, you're embedding a co-pilot in an existing product, or building sort of like a new, I mean, some call it the decision intelligence layer and some call it different,
Frankly, I don't buy it.
yeah.
um, there's that joke that I learned in San Francisco, which is that when there is a new technological paradigm, a lot of people are doing chocolate covered broccoli. So they take the old thing and they put the new thing on top, but it's really bad.
Yeah.
And so the most common example is that Like Yahoo was just slapping the old way of thinking, like putting links, and Google was the new way of thinking. You get an answer. And I think the new way of thinking with AI is you get to work with a digital worker. And it needs to be managed, it needs to be taught, collaboration needs to be a thing. You need to feel in control, you need to have trust in the output. That is a whole new experience. Slapping a copilot with a rag where you can ask questions on top of a program that was designed 20 years ago is not innovation, it's
Yeah.
laziness.
100%. 100%. Totally agree there. So let's talk about scale. I think we spoke about this idea that a lot of projects or AI they remain stuck in pilot, or even if it works maybe in one site, scaling it to like 100 or 1,000 sites is a totally different challenge altogether. So I mean, I've noticed like one of your portfolio companies, I think it's Fabric, who has
Mhm.
actually gone from 0 to 600 factories.
Yeah.
Can you sort of like give us a picture into what that journey looks like? What does it take to
Mm.
actually scale to such magnitudes?
So my experience is that if you are really serious about scaling, you need to do two things very contradictory at the same time very well. The first is you need to have a product that scales because there is insane user love. And so I always advise founders to not scale prematurely, to spend a lot of time taking extreme care of that early stage product, to have a really good product that people love, that and that can be deployed easily. And if you're trying to hyperscale too soon, it will be very hard. And so the first thing is to have an insane focus on creating a good product that scales and that delights users, and take a little more time being a small company, taking a lot of care in the product. That's phase one. Phase two is hyperscaling, and then it's like the level of discipline of the best companies that we created in terms of how to deploy is just on par with like Toyota or the US Army. It's
Yeah.
like you have that insane process, extremely detailed, saying, okay, on day one, I need those 12 data. I will train everyone like that. I will put the version one of the product. I will explain. Here are the number of people. I will talk with IT with that in mind, and blah, blah. And like, it's like absolute, like, I tell you, it's like the US military invading a new country. It is very organized. And so you need to have both. But the worst thing that can happen is you are trying to solve with a very disciplined process something that should be solved with product, because then you will fail. And the other mistake is trying to solve with product something that should be solved with the right amount of process of deployment. And so it's very hard as a founder because you're like, which is which? Like, where do I stand? And so this is where judgment and experience and being just good at your job comes in.
Yeah. And how much of a part does infrastructure play in successful scale? So I also noticed that you've built what you call reusable tech bricks,
Yeah.
which is sort of like standard data structures.
Mm.
How much is the surrounding infrastructure play
It is
as a role?
extremely important because it's the right to play. Like when one of the companies that we create spins out, usually there is an IT director saying, "Hey, but like, are you cybersecurity compliant? Can you connect to my ERP and everything?" And a random company would say, "Hey, yes, I can do it. Let me prove it to you." And then you spend like 1 year trying to do it.
Connect to it.
When it is an OSS company, they all share a shared tech infrastructure that already is compliant, that already connects to ERP and everything. And so we say, yes, we do. And as a matter of fact, we deployed 3,800 factories in the last 5 years. So we have an experience in connecting to ERPs and being cybersecurity compliant. And so you get that out of the way, which is, by the way, one of the core reasons I created OSS Ventures, because that shared infrastructure is so important, because it's hard enough creating a company, doing the right product and everything. If on top of that you need to be cybersecurity compliant on day one when you are like two coders and a dog, like it's too hard.
Oh yeah, absolutely. All right, so now Renan, I just wanted you to kind of like give us, for our audience who maybe wanting to engage with you, whether it's the builders or or ventures or
Yeah.
end users, like anyone who really engages with you. Can you kind of like give us a insight into how exactly do you operate? What should they do, and what does the process look like, and things like that?
Yeah. Thank you so much. So I have two main targets really. The first is founders who want to change the world, founders who are good at tech. You don't need to be good at manufacturing, you need to be good at tech. We take people from the tech world. Please contact us, and if we work together for 12 weeks, we go to factories and everything, we decide to work together, and then we launch a project. We are on track for half of our companies have reached 10 million recurring revenue in year 4, which is like insane in terms of track records. The other is industrials. So if you're a factory director, even if you have zero budget, because like it's free for us to come to your factory, just like contact us and like just give us a call. We get to your factory, we have a chat, we explain to you, we give you the benchmark, we say, hey, we are seeing this and this and that, and that's totally free, and we are bearing all the risks basically. So your main risk is like some time, but then when it works, usually what you pay in license fees is 10% of your gains. So it's a very rational economical decision. And so yeah, those are the two main personas that we want to work with, and we have been very lucky to have incredible partners, both industrials and founders. Like we are incredibly lucky to work with incredible people.
Absolutely, yeah. So we'll provide links to your website and all your social media links. But before I let you go, as a tradition on this podcast, I often like to ask our guests to give us a prediction of what the future factory looks like. What's your your prediction of what the factory would look like in a few years, 3, 5, 10, 20, however you wanna
So here is a prediction. In 5 years, average median pay in the manufacturing in the US goes up 25%. And 25% of new MIT grads go and work into manufacturing.
Oh wow, yeah. I mean, I cannot deny those predictions, because I think the more AI starts to eat software, the more physical world start to really look
Yep.
very useful and very cool. So totally agree with you there, 100%. So Renan, I think we've really come to the end of this session. It was such a really insightful. Thank you so much for taking your time to join me here and share your insights with our audience. I'm sure they'll really find it useful. Thank you so much.
Thank you so much.